Hey, welcome. Hope everyone's having a good morning, afternoon, evening, night, whatever part of the world you're in. Welcome to this, I say, 60-minute overview of the Hacking Enterprises training, on which we're going to pull out a few funky topics and talk about them. So, without too much delay, I'm going to hand you straight over to Will here to give you a bit of an intro to his life.
Yeah, well, I've got the luxury of chatting to you all in chat because Owen will be taking the session today. However, yes, hi, I'm Will. I co-founded Insecurity with Owen about 2 years ago, although we've worked together for probably nearly a decade now in various other jobs. Before I was a pen tester, I worked in digital forensics for a number of years. I've been lucky enough to have trained and or spoken at some of those places, and you can find me online with Stealthsploit. That's about it.
Awesome. This is me. So yeah, Owen. Go by many other names, of which I probably can't say too many on here. Before getting into sort of the offensive side, my main roles were admins, basically sysadmin for Windows, Linux, networking, storage. Did that for about a decade before moving over to the dark side back in 2012, and that's roughly when I met Will, maybe a year or so after. And then the rest is history. So we started up in .security about 2 years ago, and we've done a lot of trainings as well as obviously pen testing gigs around the not just in the UK but around the world. So it's really humbling, and I'm happy to be speaking here at X33FCon. So we're looking forward to this. If you do want to get in contact with myself or Will after this, we'll give you the relevant contact details. But yeah, if you want to, I'm Reboot user just about anywhere. Twitter, GitHub, whatever. So yeah, feel free. Okay, so I'm going to give you a bit of an idea of what we're going to be looking at, not just in the training, but what we're going to be looking at today. So like I've said, this whole sort of event, everything we've built within this hour is based on our Hacking Enterprises course, of which this is a very high level lab diagram. You can see the MS Paint skills have gone to great depths here. So basically, we have a centralized pfSense firewall. Okay, everything goes through this. Now, connecting to the lab, in November when this training runs, you'll get a OpenVPN certificate, and you'll connect to this firewall, and essentially you're going to get an instance, a Kali instance in the attacker's LAN. Now, these are fairly customized Kali instances. We've got a few funky tools on there that we will be using throughout the 3 days, of which some are going to be introduced today. Now, the first thing we do is essentially tackle dev. Now, as you can see, we've highlighted dev. It's all open. It's free and easy. There's no firewall restrictions. It's very much a case of, what you see is what you get. And there's good reasoning behind that, because morning one of day one, we wanted to be fairly sort of easy or an introductory to the lab. More so, we're using IPv6. We do a lot of IPv6 enum, exploitation, pivoting, routing, SOCKS proxying through IPv6 hosts. So we try not to really, make you too overwhelmed on the first morning. But that's gives you an intro to what you've got to come. After this, we obviously have a few more subnets, LANs, should I say. I'll just get my mouse over here to sort of target, of which we're not going to say too much now, although these are, we do sort of hint at what these are a little bit later in this webinar. But these are fairly segregated, i.e., there's only a single port or a single service on each. And this is meant to represent an external presence, really. So over here, we have an exposed Outlook web access. And over here, I'm not going to say too much, but it's essentially a management port, okay? Now, we have to have credentials to gain access to this. And this is where our first element of pivoting or phishing is going to come in. And that's what we're going to focus on, the first topic we're going to go through today. So we're actually going to send a phish and get some sort of access to one of these environments. And then we're going to use that as our pivot around. A few things to mention. We do have this management LAN up here, of which down the side, you'll see a few of the platforms we've got available. I should mention a lot of these slides are direct copies from the actual course, the actual training. We try to make them relevant to today's session, but there will be a few things that you obviously don't know too much background in, because we just don't have the time to go into everything. But essentially, this is where GoPhish, the phishing platform, lives. It's where our elk stack lives, and again, we've got an introduction into logging, monitoring, etc. in the environment. And our CTF platform. So from the end of day 3 onwards, we essentially fire up a whole load of new hosts with new challenges, capture the flag is, crazy. We've actually got another subnet that we don't even show. In fact, I think we've got two subnets we don't even show because this is just relevant to the CDF. So there's loads more stuff to attack. And then we have this DNS server. Well, why are you calling out a DNS server, I hear you ask? And I'm glad you asked that. Because essentially, this DNS server is going to be treated like our public, Google's 8888 or OpenDNS, etc. This is what we're going to be using for our out-of-band data exfiltration, of which we are going to go through later. A very small subset of it, but we're going to go through later. So we've got some funky stuff coming up, if I do say so myself. And we've got some pre-recorded demos, okay, because we have done the live thing in the past, and 90% of the time, live's not bad. But when you're on a time restriction like we are today, and you've got thunderstorms going on in the background, the last thing we want to do is risk a live demo. So we've got some pre-recorded video on a very sort of basic level. So let's put focus back in and go through a few of the topics we've got in the training, and again, what we're going to cover today. As you can imagine, the ones highlighted in blue are essentially what we're going to cover today in some element. We're not going to go through anything and everything. We just don't have the time. It's going to be a light touch, but hopefully an interesting one for everyone that's joined. But you can see there's loads of stuff that we cram into these 3-day sessions. We will be doing the phishing first. So we're essentially going to have a little look at some customized phishing campaigns in a moment. We're then going to use the elk stack to try and find evidence of this phish before we go to something completely different for the end of the session, when we're going to be looking at out-of-band data exfiltration with DNS. Okay, something to mention, and this is new for our 2020 edition, although saying 2020 now feels, this year feels like it's really gone on some. I feel like I'm in 2022 already. So although I say it's new, I've seen this slide quite a lot recently, but that's because of the, the whole situation we're in. So, new for our 2020 edition, we have the MITRE attack framework references. So this is an absolutely, it's really, really handy to sort of look into. Basically, the way we've used it is in the slides now. You'll see a reference down below here. So you'll see this in the top corner of the slide. So if we're talking about this one here, which I believe from memory, and do quote memory, is WMI event subscriptions, you'll be able to see that in each slide. So you can go through these later on and say, okay, look, I want to get more information on WMI event subscriptions. Let's see what MITRE say about it. Okay. So basically, these will be, hopefully for your own use after the event. Modern infrastructure, again, something we put in just for this. So we like to keep this training up to date. We really like to keep it up to date for our own decrement sometimes. So sometimes we think, okay, this will be a fairly easy update. Let's put the latest signatures on from Windows Defender, or let's move to 1909 for Windows 10 disto. And yeah, there's obviously fallout from this, but it's for our own learning. We build our own sort of infrastructure to sort of learn from ourselves, as well as obviously develop training material. So that's why I've got this Wikipedia article here, really. When we started this training out, we started on 1803, Windows 10, okay? Since then, we are now on 1909, and the training has gone through numerous revisions. When we migrated to 1903, there were some big Windows sort of security enhancements that we really noticed, i.e. they broke a few exercises. So we've now taken this a little bit of an alternative way. We've basically gone down the living off the land route, which is obviously very popular, but that makes it very dynamic from our point of view. So if something doesn't work, we can quickly change out X, Y, Z and, essentially substitute something in its place rather than having to rebuild from scratch. Again, real life scenarios. So we are running on 1909 in our lab. We're generally sort of 6 months behind the last release. So when we update to 2004, it'll be in the latter part of this year, maybe before the X33F training. I'm not going to promise anything. It very much depends on how the rest of this year pans out with the sort of schedule deadline for this. But we keep this very relevant. Incidentally, we ran this at Black Hat USA virtually about 2 weeks or a week ago. And just before the training, we put, I say just before, about a month before the training, we update the signatures for Windows Defender. We make sure everything's very current, very relevant. And we obviously test out things before going in and doing this live. So like I say, there's a lot of work goes into sort of keeping this sort of stuff current. needless to say, if you're going into an environment and you say these days, what have you got? And the client comes back to you and says, I'm looking at a Windows 10 environment. You think, well, okay, is that Windows 10 1507 or is that Windows 10 1903 or something like this? There are big differences from the security perspective. So, it's very much harder to understand from XP to Windows 7 to Windows 10. Hence, if we can make something work in the lab, it's going to work in an environment, obviously depending on other solutions, etc. they may have in place. But yeah. Right, enough rabbiting from me. So, phishing. Let's talk a little bit about phishing. I'm aware, and I'm hoping Will does his usual thing and tells me to wrap it up, because I do tend to talk a little. So we're going to talk a little bit about phishing. We're going to talk a bit about living off the land. We're going to talk a bit about AppLocker, and we've put crash course on there. This was a last-minute addition to this slide deck because we needed something in there to bring some relevance to the content we're showing. So it is a crash course, but hopefully it will do everything we need. Okay, so typo squatting, the first sort of attack, if you like, or a technique, should we say. This is something we use in real life. And I should say that virtually everything we use in this training is based on some real life element, okay? So in our instance, we have a target of insecurityenterprises.com. That's going to be the target, or that is the target throughout our training, all right? Not spoiling anything there. That's told on day one, exercise 1. So what happens if we try and perform a typo squatted demand? I've got a very large plane going overhead now, so I apologize. What happens if we perform a typo squatted attack by substituting the lowercase I for a lowercase l? I mean, even to a trained eye, that looks very similar. Now, that's just obviously one example, but this is essentially where typo squatting is coming from. So what we can do from a blue and red perspective is use a tool like DNS Twist. Many more exist, many more sort of ways to actually produce these domains exist. But we can use DNS Twist with the registered switch against our legitimate in.security domain. The reason we've done this is because in.security it has a very small number of iterations. It's a small domain, so it's prime for an example. But if you see the registered domain, you'll get the legitimate in -security.com, and that's all well and good. If we saw something that could potentially be spoofing our domain, we then, as a blue teamer, try and block this at the perimeter. If let's take Microsoft as a prime example. If Microsoft.com is the legitimate domain, we have Microsoft, someone's registered it with a 1 instead of an I. Why don't we take the proactive approach and block that from the perimeter? So then even if an email does get through, the user clicking on that will not get anywhere because it will not resolve, it will be blocked. It's, it's defense in layers, essentially, defense in depth. So from a blue team, we can see if there are any registered domains that resemble our own. From a red team, we can remove this tag and essentially try and find an iteration on in.security or insecurityenterprises.com that looks legitimate enough that we can potentially pass off and hope someone clicks with. Needless to say, the reason we didn't run in-security enterprises through this is because we get tens of thousands of variants due to the length of the name. There's so many iterations, variations of it you can have. So just be aware of that. Okay, I think this is the first. I didn't have one in the last. I know this is the first MITRE attack reference with regards to HTAs. So that's what I meant from the initial intro. Okay, so HTAs are going to be very relevant in this 45 minutes or 40 minutes or whatever we've got left now. They are essentially HTML applications, and they're launched by MS HTA on Windows. That's going to become very relevant when we look at our ELK stack. Okay, I'm not going to read this whole docs reference from Microsoft, but in short, HTAs pack all the power of Internet Explorer, get those whistles going, without enforcing the strict security model and user interface of the browser. So that may already have your attention, okay? It did ours, and it has, I think, for the offensive community for quite a while. So this is how we're going to start. We've got a template. We're going to build in this template to make it somewhat offensive, okay? In a offensive as in a nice way, not offensive. It's based on VB script, okay? There's some various properties we can look at. First one is positioning. Not too worried about that. Second one, we've got this command variable, okay? Now we're using the PowerShell test connection commandlet. We are lead hackers and we need those pings. So we're going to be pinging this IP address. I think you agree this is not something you generally send to a victim of a Fortune 500 or whatever. But hey, that's good enough for this proof of concept. We'll be increasing this in a moment. Then we've got set this to hidden, wait for the command to complete before continuing on, and that's it. All right. So that's our payload or our template, but we have to deliver this somehow. And the delivery is going to be through an embedded iframe. So at this stage, we've got our typo squatted domain, linsecurityenterprises.com. We fired up GoFish, which we'll look at in a minute anyway. And we've cloned the insecurityenterprises.com website, okay? Something like that. In the back of our clone, we'll go to the source, add this iframe tag, and essentially what we've got here is it's going to pick up or get the source of this iframe from this IP address, which is Kali in our instance. So on the lab, this is the addressing of our attacking hosts. In reality, this would be something in AWS or DigitalOcean Droplet with a domain, whatever it may be. And it's going to be calling launch.hta. So we're hoping there's a web server serving this out. We've got an application, width 0, height 0. So it's hidden. All right. That will become important later. We'll probably reference it again. Okay, put that to one side because we now have to generate a payload. And this is where we're going to live off the land and do a lot of this ourselves. So Windows 10 ships with a C# compiler. In fact, it ships with numerous ways to compile C# code. I'm going to start getting myself in a tongue twister in a moment, especially when we drop shells into the mix. But we're going to start looking at CSC. Okay, so CSC lives in these locations, 32-bit, 64-bit. We're going to use CSC to compile some C# code. So in this case, we've got, I should stop reading those comments. So in this case, we've got our input as Windows System32 spool drivers color, and it's called code.cs. Why have we chosen this path? I'm, again, glad you asked. We'll come back to that in a moment. And when we've compiled it, assuming we're getting no errors, we're going to drop it into the same location, but called output.exe. All right, that's on a very high level. So now, AppLocker, crash course, because we need it. And this is where, in reality, in the course, you don't get all this information, bam, bam, bam. They'll be very much segmented and make some sort of relevant sense. This is just background information we need for what we're about to do. So, okay, yeah, AppLocker builds on software restriction policies, so something I was fairly familiar with back in my days as sysadmin. It essentially allows you to create an application firewall. So, you allow or deny applications, all right, on a very low level. We're going, or high level, should I say. We'll be going into a lot more depth in 3 days. Here we can't. We can create various policies to affect various sort of file types, if you like. So executable and script files are generally the two file types that are configured in an environment. But as you can see, you can configure AppLocker to cover many different things. If you're feeling brave, go for DLLs and whitelisting, and you're going to have your month cut out. But yeah, we can essentially enforce these or audit these. So in this case, we're going to say we're enforcing executable rules. Okay. Right. We can create an allow or deny action on each rule. So in this case, we've got allow everyone. Okay, so everyone can do something. We have got a condition. So this can be based on a publisher, a path, or a file hash. So a certificate, the path of the file, does it live under C, Windows, or somewhere? Hash the file. So are we going to say deny cmd.exe from running? Are we going to hash that file? If we do that, that's massive upkeep because you've got to think every update to cmd.exe or every iteration of Windows 10 we go through, that file hash is likely to change, and hence it's going to make our condition irrelevant. And if we forget about this and we are, say, blocking cmd, we don't update that file hash, then the aspect, the prospect there is someone gains access to this and does some malicious activities or whatever it may be. So although it's very nice if you can just do everything via file hash, in reality, from the admin side, it's quite difficult to manage. So generally, we see a enterprise in, again, real life, having a combination of sort of 2 or 3 of these. Okay, so, right, AppLocker rules. I'm not going to go into the background too much, but you can see on executable, we've created default rules. Default rules have, 3 default rules. The everyone group is allowed to execute from the program files folders. So this is 32-bit and 64-bit variants. Everyone can execute from Windows, and admins can essentially, do whatever. You're an admin. This is default rules in an environment. Generally, there's very customized rules in place as well. But at the moment, we're talking about default rules. That's just the sort of precursor there. So going back to our example of living off the land, I know it was only 10 minutes ago or 5 minutes ago, but it feels like a lifetime. CSC, if you recall, we said, let's save it to Windows System32 spool driver's color, call it output, okay? Now, why are we saving it there? Well, in the ultimate AppLocker bypass list, I'm sure you may have heard of this. If not, do look it up. Nice GitHub repo. One of the sort of things we're giving away here are the default writable paths. So on a standard default Windows 10 install, a number of paths are writable by a sort of normal user. And again, it's hard to define a normal user, but someone that's say a domain user or a local user. Okay, so a domain user can come in. Say we've got Bob. Bob's always a prime example, and he can write to Windows System32 spool driver's color. And not only can he write to that, he can now execute it from it, assuming, here we go, just back one slide, default rules are in place and they haven't been modified because everything under Windows is good to go. Now, generally, we assume that admins don't tinker with Windows AppLocker too much, and we're hoping they're leaving it in its default instance. You know, they're thinking everything from Windows is good. But in reality, we should sort of limit that. And if you are on the blue side of things, go through the folder listings from the ultimate AppLocker bypass list and really sort of tighten those ACLs because they can be abused. Why have we chosen spool driver's color? I can't tell you. Will and I, this is our default thing for years. We always go to this one location. There are easy ones out there. But yeah, we always use this, and hence it's if you see something in your system from this location, you can blame us. That's obviously not on record. Okay, so again, going back to our CSC. We've now got something to deliver, okay? We've got something to compile some code, but we haven't actually got any code. So for the purpose of this, we've got this. This isn't our gist. This is just a very handy gist for a simple reverse shell. Now, this is only 70 or 80 lines of C# code. It's available from this gist up here. And we've used this for quite a few sort of examples. It's really nice because it's so small. And what we have to do is essentially start a listener on our attacking host. So Kali listen on 443 using netcat or something similar. We compile this using CSC. And we then execute it by calling our compiled, we're assuming it's called shell.exe. And we're going to connect back to our target IP. So Kali on port 443. Again, you can apply this to real life and have those droplets in the sky. Be aware, though, that this isn't proxy aware. So you would have to modify the code or find any other C# code to essentially do the job for you. This is the beauty with living off the land. We can, substitute the payloads at will, really. So yeah, this is the sort of the payload we're going to use. Now you might be saying, well, look, hang on, if I can compile this, I've already got interactive access to the box. I've got some sort of CLI access. Why do I need a shell? And if I do want some persistence, there are better ways. Well, this is where we're going to put it all together into this. We're literally jamming this payload into this HJ template, and we're creating something wonderful. So here we go. We've got the new code in yellow. Okay, we're using PowerShell with the wget alias to grab our dodgy C# shell code. There we go. There's that tongue twister. I knew I couldn't resist it. From our Kali instance. So it's listing on it's got a web server running. We're grabbing it here. And we're saving it to that favorite Windows System32 spool driver's color, and we're calling it shell.cs. And we got the semicolon, so we're going for the next command, and we're calling CSC, the 32-bit version of CSC. And we're basically calling our shell.cs. We've really got to name this from shell.cs. This is too much. We're renaming this. We're compiling this to shell.exe in the same location. Okay. So assuming there are no compilation errors, we now have shell.exe in the driver's color folder. Next command, we are then calling this whole thing. So we're calling shell.exe, connecting back to our Kali instance, our attacking IP on 443. So at this point in time, yes, that user will get a pop-up saying, are you sure you want to be doing this? There's all sort of security issues that can be had here. And we, from the red side, are hoping they're going to click, yeah, just do whatever. A bit like your Office macros. And assuming they do, then shall be had. However, again, another stage, we've got to get this to them. At the moment, we have everything now. We are on the brink. But we need to send this whole payload and get them to sort of interact with it. And that's where the whole fish comes in. Now, this is one of my favorite parts of the training. Trust me, I've got a few because there are a few funky things we do. But phishing is quite interesting because there's a lot that we've got going on, a lot riding on this. So this is where we're going to be using GoFish. Now, in reality, again, when we do our phishing engagements, we love this framework. It's freely available. It's regularly updated. It's very customizable. Can't say enough good things about it. Link at the bottom for the actual documentation, and obviously feel free to clone it. Right, so we have to define a target. So under users and computers, that's Active Directory. Users and groups, we basically have to give it a target or some targets. So what we need here is a dedicated user, and luckily that's what you get. So every person, or every player, every delegate in the Hacking Enterprises training gets a dedicated target. So when you actually get access, you get on your dedicated infrastructure for said user. So I think we're using kfire from memory on this one. So we've got kfire in securityenterprises.com. We then have to create an email template. So an email template, you can sort of see here, we've got some variables or some placeholders essentially that are going to be filled out. So a bit like your mail merge, going to substitute kfire for Kate or whoever they're called. And the important part is the URL. So this is going to place our URL that we're going to define at campaign time. When they click on the URL, it's going to go to the landing page. Now, the landing page is where the magic happens. So this is the thing we'd be cloning in real life and then putting that embedded iframe in and that sort of thing. Okay. Sending profile in the labs, you don't have to worry about. But essentially, this is your SMTP server or services. In real life, that's the tricky bit. You don't want to get blacklisted. You don't want to go to spam. You want to have a good reputation. For this, looking at the time, we're obviously not going into that sort of detail. Okay, so demo. This is where I should have if I just open this video up, it's only a small video. Oh, look at that. It's even open on the right screen. Let's hope this means good luck, eh? Although what can go wrong in a video? Hopefully everyone can see this. You can see this is our GoFish instance. We've even got Cabana up in the background. The beauty with that lab is you get access to all of this from the get-go, so you can monitor your own sort of attacks. Right, let me start this out. I'll be pausing it. First things first, I should mention we are attacker 124 or hacker 124 in our case, of which that means our target is defined as kfire, as we'll see in a second. You'll see the example from the slide is essentially the same here, except we substituted relevant IPs out. Nothing more to say at that point. And we've got our shell.cs C# code. Okay. Again, you can substitute this out into whatever you choose, really. It's just some C#. We're going to create a session. So we're using a screen for this so we can listen in the background. Start netcat out on 443 because we're expecting a connection back, and that's the shell. All right. We're going to start an HTTP server up. So this is essentially the thing that's going to serve out our launcher. All right. Now, one thing to mention, or a few things to mention, yes, this is Python 2. I know this was recorded at the end of 2019 for another demo using this. We're now using, everything has been upgraded. We're using Python 3. So same principle, but yeah, before everyone shouts in the comments. One thing to mention is we're using port 80 to make this realistic. Everything we're doing here is simulating a real life pen test. So from day 1 to day 3, we're going through the whole pen test stages. We don't go module 1 OSINT, module 2 password cracking. We essentially do it as a normal pen test progresses. Okay. Again, I've gone off piste on that. So let's just go back to our campaign. So we've got everything set up. Yeah, kfire is the target. So we've already imported that user. And we've created a template, okay? So here we've got the very basic. It doesn't have to be too convincing. At this point in time, our insecurity enterprises employees are going to click anything. They're paid well. We've got our this is our page that it's going to go to. So basically, when they click the URL in the email, it's going to go to our landing page. In our landing page, we just have the title of pwned. Okay, great. In real life, that's not going to go far. That's not going to get you many clicks. But for this purpose, it's fine. We've then got our hidden iframe that's going to connect to our Kali instance with that, hidden 0 height, 0 width, etc. Let's continue this on. And we've got everything we should need. Awesome. Onto a campaign creation. So this is where, as my laptop fan really ramps up, this is where we just create a campaign. Now, nothing too involved here. We've only got one email template. We've only got one landing page. We only have one target. What we do need to define is the URL. So you can see we're using linsecurity.enterprises.com. Now, this goes back to the whole typo squatting attack. We want to make this realistic. We've already pre-registered these domain entries, or DNS records, sorry, in the lab. And this goes to the relevant attacking infrastructure. We want to make this convincing for yourselves, not even the insecurity enterprises users. So hence, yep, this is genuine. Let's do this. Okay, Kfire is our target, and we launch this. Now there'll be some waiting. The waiting, it can be 5 seconds, can be 60 seconds. They're very the insecurity enterprises employees are very good at checking their email, but it still could take a little while. Now you'll see, just going back to this just a little bit, you can see that you instantaneously got email open and click link. Realistically, that's not simulated a real life environment. You might get lucky and someone opens an email on the Monday, then on the Thursday they might click the link. So this is very time dependent. In the lab, yes, we've got some PowerShell scripts. So the PowerShell scripts, it's bang bang done. So it's going to be all or nothing. But just to sort of show you that. Okay, back to our Python server. We've got a couple of 200 OKs. We've grabbed this launcher HTA. Awesome. We know that's essentially rendered, if you like. It's been yeah, Will, you're right, they're not scripts, they're real employees. Sorry, I've got to stop saying this.
Sorry, I couldn't resist. God.
We've got the launcher HJ that has the code in it to wget the shell CS, so we know that's executed because we've got a call for shell CS, again a 200, so that's good. And you'll notice, not necessarily in this demo, but in the actual lab, there'll be a delay because Windows Defender still does its stuff. You'll see the CPU spikes of these VMs go up, but they go through absolutely fine. Like I say, modern defs. So we're going to interact with the shell, and here we go. This is our compiled 70 line sort of C# shell. I thought I got a way of saying that again. So now we have a level of access. All right, let me just minimize this, cross the right one off. And this is a sort of example of what's just happened. And we have these catch-up slides through the fairly complex, lengthy exercise because there's a lot that's gone on there. Yeah, needless to say, in the last half an hour, let alone the actual training. But essentially, the attacker has sent an email. The employee has gone, yeah, that's fine. I want to set my password. Clicked on this URL. The URL is then served out from the phishing server. This hidden iframe is served from the attacker's host. Python is used to serve this. The victim clicks, yes, yeah, do whatever you want. And we then get this shell back. That's essentially it in a nutshell, okay? Right, just a bit more about the lab. You're never left behind. Very sort of Liverpudlian, but yeah, this is very true. You're never left behind because there are, from memory, 3 key elements to the lab where we need some practical exercises to have succeeded. So you'll be given a amount of time to do exercises throughout the lab time, but there are 3 of them that really we need to progress, okay? Because there are various sort of hops we have to do and a lot of pivoting, a lot of sort of jumping through various subnets. We need some sort of access. This is one of them. So even if, say, we've got 100 fishes later, nothing's happened, we're losing the will to live, laptops ended up on the floor, whatever may have gone on, we've got to back up, okay? This is just an example. So you can come in, you can say, look, this is what you need to do, instant shell, double click the bat file, you're good to go. We have simulated a phishing attack in less than 30 seconds. So we have these strategically placed throughout the training. Right, now I realise I've been rabbiting on for quite a while because we're on to the last 20 minutes, although I'm taking that extra 5 at the start, so, I'm giving myself a bit more. We're going to talk a bit about monitoring now. Because this leads on quite nicely from the fish we've just done, we've now got to look to see if we can sort of see any remnants, okay? So we're going to have a look at the lab configuration with regards to ELK, Sysmon, what's going on in the background, not just on Windows, but on Linux hosts as well. And then we'll dive into the sort of intricacies of that attack. And again, this is slide-based content. We don't have any video for this one, although there is 1 more or 2 more videos coming up at the end for the last exercise. Okay, so Sysmon. You've probably heard of Sysmon. You've probably used Sysmon. If not, do it. It's free. It's a fantastic, nice little agent from Microsoft. Sysinternals now owned by Microsoft. What essentially we do is deploy this to hosts. So in the lab, it's on all the Windows 10 hosts, on all the servers, Windows servers. And essentially we've given it a config file. So the config file is based on the Swift on security config from here. Well worth a look. It's really nice starting point. Okay, we've customized it to catch a few events that weren't in it when we deployed this initially about 12, 18 months ago, and it's been added to since. But yeah, essentially this is a really nice template. It's really being modified a lot, regularly updated. So definitely take a look. So essentially, when you've configured Sysmon, you'll get a Sysmon log in your event viewer, and you can see whatever you're essentially capturing now. All right. So that's great, but everything at this point in time is local to the host. And this is where Beats agents come in. So there are numerous, again, as you may imagine, in the world of IT, there are numerous solutions to numerous issues. We are using Beats agents because we're heavily in the Elastic's domain at the moment. So we thought, well, why not use Beats, which is, again, from Elastic. So we have FileBeat, which is on all the Linux servers in the lab. So this ships off our file logs, etc. Then we have AuditBeat on all the Linux servers, which ships off all the audit logging, assuming it's configured. So in this case, and the prime example we give is SSH brute forcing, something like that. You've got a failed login attempt. We want to monitor this. So all those sort of things go to AuditBeat. That is shipped off and sent to our Elastic Stack, which we'll look at in a second. We then have PacketBeat on a single system at the moment, and this is the corporate domain controller. There are a few domain controllers. The reason we have it on the corporate domain controller will become relevant during the training. I'm not going to say too much now. We don't have it on all of the Windows hosts and what have you, because we found that depending on the network activity and the utilization, obviously, it can be quite intensive. So we try to use it minimalistically, hence why it's only on a little bit. We then have WinLogBeat. I think the key is in its name. This is for your Windows logging. Okay, so essentially you can ship off our Sysmon logs and what have you. And again, we'll look at this. This is on, should I say, this is on all the Windows clients and servers in the labs, and we'll look at this in a moment. Okay, going to ELK. So you may see a fair few references to ELK, Elastic, etc. It's regularly updated. The release cycle is aggressive. It's very good. We're getting new features for virtually nothing. Well worth a sort of trial, or get in there. We have got essentially Logstash set up in the lab, but it doesn't do much in our case. So generally, this would ingest the data and then perform set activity on it or process it. Okay. In our case, it's actually just taken the data and popping this into the Elasticsearch backend. Now we've used it in case we want to add something later on, but at the moment it's just sitting there as a bit of a not doing much agent. But yeah, it's putting the data into Elasticsearch or feeding the data to Elasticsearch, and that's essentially our DB. We then use Kibana, which is the front end. So I don't know if anyone has used Kibana or uses ELK in the background. It's a beast to set up, or can be a beast to set up, but when it's running and you've got things actually feeding into it, it's really, really sort of, I say easy to get to grips with. When you learn the filtering and the various fields you can have in views, it's really useful and sort of nice to have on hand, and you can quickly query masses of logs, as you'll see, when you sort of start playing with it in the lab. So yeah, this is our web front end that we can use throughout the 3 days to query it. And see what's been captured. So to give you, and we've jumped a lot of slides now, okay, to give you an example of why MS-HJ was interesting to us. We haven't had any intro to Kibana. We've had nothing to say this is what a filter does, because we just don't have the time. But essentially, this is what a filter is, or what a filter can do in Kibana. So agent.hostname is the field we're after. The target would be our compromised host. And we're looking for something with a parent image of MS-HJ. Now, that's a very focused attack, or very focused search, should I say. Generally, we want to expand that. So in the case of the fish, we could have Kfire came to us. They said, look, about 2 days, 3 days ago, it could have been a week ago, I clicked on something. I'm not sure if I should have done that. Something might have gone on. Firstly, thanks for telling us, because I'd rather, I don't know about anyone else's view, but definitely rather know this than that just going undetected or unsort of reported. Thanks for telling us. We've now got something to look at. We've got some focused searches we can do for the username Kfire. So yes, in reality, Kfire is not going to know that it was an HGA based attack, but what we can potentially do is use LOLBAS to widen our search. So if you've not seen lolbash, it's something we heavily use. There's a GTFO bins equivalent for Linux, but as we're talking about Windows, we will focus on lolbash. Lolbash is absolutely fantastic, a really nice resource to find binaries that come by default on a Windows 10 installation. So you can see, although we've only got a few on here due to the screenshot size, we've got AT-Broker and Bash. Although Bash is rarely used in an enterprise environment, you can execute, and you've got an application whitelisting bypass. Okay, so you can see they can be used for other alternative means from an attacking point of view. So we will use this in the lab, but not just now. So what we're going to do is grab, and I admit, looking at this screen, you might think, what the heck? These guys are just spamming text to the screen. You're not far off the truth. So what we're doing, just to break this down a bit, we're looking at the winlogbeat index. So this is the Windows login. We're looking for the user, say kfire, okay? And we're looking for a parent image. So a parent image needs to exist, but we don't want the parent image to be explorer.exe. So we're not interested in anyone coming along and going start cmd.exe, start calc.exe, okay? However, we are interested if any of these images, i.e. these exes, have executed. So AT-Broker, Bash, bits admin, and so on. This is essentially a dump from lolbash. Now, lolbash is being continually updated, so you would have to do this fairly regularly to make sure you're on top of the known breakouts. But essentially, this is a collection of the lolbash binaries at the time we wrote this. And then we're going to filter it down by just showing a few fields that may be of use. So in the next screenshot, you should see what's gone on. You've got your parent image here and the actual executable down here. So if we start from the bottom, we've got SVC host is calling MSHTA, MSHTA is calling PowerShell, PowerShell is calling CSC, CSC is calling CVTres, and then PowerShell, there's a bit of a break here, but then PowerShell calls shell.exe. Now, yes, there's some missing sort of entries in here, and we can dive into Kibana and look for, 5 after and 5 before events and that sort of thing. Again, we're not going to go into here, but it's absolutely fantastic because we can delve into sort of A, from a blue team, see what's gone on, B, from a red team perspective, you've just performed this attack. You can now see what sort of traces you're leaving. How can I alter my sort of artifacts? How can I sort of change the sort of artifacts I'm leaving and so on? So it's a really powerful tool to have, as in aggregation of logs. And though we've only just touched the top of it, in this next section, blimey, I'm going to need a Red Bull or something in a minute. But in this next section, at the end of it, we'll show you where a visualization in Kibana can be of real use, okay? Assuming we get time. I'm looking at the time and thinking we may not, but we'll see how it goes. Okay, so today we've done a phish. We've looked at evidence of said phish. And these are, again, topics from the training that we've only had a very light pinch of, okay? We haven't gone into any depth yet. We just don't have the time. And I keep saying that, I realise. Finally, we're going to look at one of those topics that's a bit out there. So this is essentially right at the end of the 3-day training. We'll look at some persistence and exfiltration methods. One of the persistence mechanisms is WMI event subscriptions, and we combine that with DNS shells, okay? Now, we couldn't get all that into the last 9 minutes. So what we've done is just take the DNS element and shown you a bit about DNS exfiltration, okay? Beforehand, we have to talk about DNS and how it normally works on a very quick sort of slide deck, should we say. So we've got our victim. A victim has been asked, he's clicked on a link. I'm just going to take a sip of coffee. Oh, yes, that's good. They clicked on a link, and the link's taken them to attacker1.pwn.network. Now, they know nothing of this. It's not in a recent cache, etc. They asked their recursive server. So in our enterprise environment, we've got a DNS server or some DNS servers we can ask questions to. Now, the recursive server is going to look at this and say, look, I don't know the answer. I don't have it in my cache. I can look it up for you. I mean, it looks a bit dodgy to me, but I can look it up for you if you want. So here we go. Now, we're going to ask for the TLD of .network. So we're going to the root server, and we get this fictitious IP address, okay? But we're told that .network lives at said address. We can then go to, and this is obviously very simplified, we can then go to the TLD server of .network and say, hey, do you know of pwned.network, this legitimate domain that I need? And the TLD server of .network says, yeah, look, it's down here. Now, at this point in time, we are talking to an authoritative name server for pwned.network. Okay, so us as an attacker, if we have access, we have control of an authoritative name service for said domain, in this case, pwn.network, we can do anything. All right. Now, in this case, we're explaining how DNS works. So, yeah, we'll say, okay, yes, the legitimate record for attacker1.pwn.network as is at this fictitious IP. Here you go, Mr. and Mrs. Recursive Server, which is then returned to the victim. And the victim say, yep, have a nice day. Try not to get pwned too badly and see you in a week. That's it. Okay. DNS in a nutshell. Look at that. So now, some simple exfiltration over DNS before we go into shells. So a simple proof of concept. In this case, we're using attacker 128. Okay, we've got TCP dump running on UDP 53, and we're just listening for traffic. Okay, so you can see we get this request for pcushing.attacker128.pwn.network, and that is because at the bottom here we've got a second window which is our victim. Okay, so the victim has done an NS lookup for the environment variable of username.attacker128.pwn.network. Now, to cut a very large topic short, every delegate in the training has an authoritative name server that they are in control of for their relevant hacker ID. Okay, and it comes back to their Kali instance. So essentially, you can do as you will. You are a DNS server. You are Google. So in this case, we can see this request coming to us, and we're looking for the variable that's been translated to p.cushion. Now, a username is not that interesting, so we can actually get data over this, but due to the restrictions with DNS length, which I think is about 253, we have to cut up a lot of data and encode it. Okay, so this is a really handy resource. So from Not So Secure, so this is a really decent company. A full disclosure, our ex-employers, so we really rate them. But they've done a really nice cheat sheet on how to chop up this data and then get the requests and the requests and reconstruction queries constructed, so you can get that data out of an environment. Now, we've got a variation of this in the lab, and we're going to have a look at a video of this exfiltrating from a blue team perspective. However, we do exfiltrate a password database over DNS. It's one of the exercises. Now, in reality, even in the lab, it takes about 13 minutes. It's not quick. And you have to chop up a lot of data. It's not a big file, but it's very noisy, obviously, getting all this data out. Okay, so now we're going to talk about shells, because that's where the fun is, isn't it? Some sort of C2 operations, etc. Again, very quick overview, especially given the last 5-10 minutes. We've got DNS-CAT2. Now, you may have heard of DNS-CAT2. You may have heard of iodine, something similar. It's essentially, some shells over DNS channels, essentially. So I'm not going to go into each and every bit of detail, but essentially this uses the DNS protocol the way it's meant to be used. And by that, I mean we don't have a direct connection on UDP 53 from the target to the attacker's box. We go through the legitimate TCP channels. So the recursive server internally, out to public DNS, and then back to attackers, however many routes that goes through, which is really nice from an attacking perspective. As we will see, it's quite noisy. So if you monitor this, you should see these sort of attacks. Excuse me. Right, DNS-CAT2 comes with server and client binaries. However, if you want something on the PowerShell variant or the variation, Luke Baggett, the GitHub repo here has a DNS-CAT2 PowerShell script, something we do utilize in our WMI event subscriptions in the actual lab, hence the sort of syntax you'd need. Right, now we're going to have a little look at DNS. So if I bring out DNS, we're back onto attacker 124, but why not? Okay, let me just start this up. So this is using one of those funky sort of CX command lines from Not So Secure to cut up the data. Okay, so essentially, first things first, we need to use TCP dump. Now, to be honest, we're using T these days to sort of filter this into a text file. All this is doing is listening on port 53 UDP. It's essentially writing this to a DNS text file and then tailing this out to give us a live representation. We did have a problem with T once in a while when it didn't work, so hence we had to get this bodge. But now T's working, we can get the same thing from it. So essentially, that would listen. From our attacking box, you can see an example. I'm not going to go into the depth and how we've got this file and what's doing what, but essentially, we've got this KDBX file. We know the password although we don't know in this 1 hour segment. We know the password to it, so we can get access. And we're essentially going to use one of those one-liners to chop it all up, chop up the data, and exfiltrate this via DNS. And you can see when we start this going, here we go. In the background, you can see these queries coming our way from the attacking host, because just going back, I was trying to switch windows there in a video. That shows you how much I need a Red Bull. But you can see this is the, if I pause that, domain we're in charge of, the Cali 124. Okay, so it's coming to our attacking domain. So as a delegate, this is what you'll see from your authoritative name server. So when it's finished, we can then use another one-liner to reconstruct this data, again, from that excellent cheat sheet. And we can basically reconstruct our password vault, assuming we've lost nothing, as in nothing's got corrupted in the transition. And we can drop into our KeyPass database, of which we know the password, you know, are completely unrelated to what we've done here, but we know the password of, and we've now got access to, you know, all the secrets that they say. Okay, I'm going to pause that there because I don't want to give too much away. Let's just minimize this and go back to here. Now, what I will show you, because I think we've got a couple of minutes, don't know if this will interest you or not, but hey, this is it from the same attack, maybe a different time, but the same attack, but from a blue team perspective. Okay, so this is a visualization in Cabana. Again, we give you access to this in the environment. Just to quickly explain what we've got. We've got an inner slice and an outer slice. So the inner slice is the top level domain. So say that's google.com. Okay. The outer slice, each slice represents a subdomain. So is it mail.google.com, drive.google.com, and so on. Okay. So what we can see, and in fact, I'm going to move this up a little bit. If we focus in on our dodgy domain, here we go. Let me just pause that. We are focused in on pwn.network because we know it's our iffy domain. We would have done some investigation beforehand. But you can see straight away, the pwn.network has loads of different subdomains. But if we see this speeded up, you know, if you've got this on the wall of your SOC, that's going to look very suspicious. We've got numerous subdomains, per se, going to this pwn.network essentially domain, which straight away, you know, that's not normal. That could look very suspicious, and hence why I think it's a good visualization to sort of show. Okay, I've realized I'm dead on time, and I've only got a few wrap-up slides. So example exercise. So yes, like I said, this is an example of the exercise we've just done. Very cut down example of what we just done. So these are the sort of things. We get a hands-on WMI and event subscriptions and DNS channels. You saw the DNS side of things, or a bit of it. We're going to be trying to do two parts to it, essentially using built-in commands to see if we can get stuff out, and then going the extra mile, which is your sort of really, I say hardcore, but funky stuff. You get cheat sheets. So how do we go through this? Everything is detailed, you know, and we explain bits as we go through. So, you know, this is exactly what's going on. We give you various resources that may be of use, and so on. And obviously, all the content that's relevant to said exercise is gone through before we actually get to this point in time. This is just an example, in case I didn't get a chance for that video. This is just an example showing you exactly what you saw in, you know, in that video just then. One with a sort of bar chart showing the most popular domains, and one that we've just split down in the pie graph, the pie chart. Woof! Right, I think actually for me, I've not done too badly time-wise.
I'm very impressed. You deserve a drink, Owen, after that.
Yeah, I think it's going to need to be stronger than coffee. But rude. But yeah, if anyone's interested in this training, we do have the 3-day version of this going on virtually for obvious reasons at X33F later in the year. Do get in contact. I think we've even got, hang on, last slide here. We do have a, after the training completes, we do have the Slack channel for any normal chat. We do have 14 days of lab access.
Just to jump in there. Sorry, I'll just jump in. This particular slide is out of sync with the actual offering at X33. It's 21 days, not 14 at X31. So I just wanted to make that note, because that extra week is very, very important. You know, this is a virtual training. We can't be there in person, and we want, you know, typically delegates get 2 weeks, but you've got an extra week's access to that. It's 21 days afterwards. Sorry, carry on.
It's almost like an early Christmas.
I know.
That's so yeah, just to sort of say a few more things. Yeah, you get access to the CTF that I briefly mentioned. As Will mentioned, it's 21 days, and there's loads more challenges in there that, you know, will keep you busy. if you've got any questions, do ask them in chat. But, incidentally, after this, because I realise I've rabbited on a bit, but after this training, feel free to ping X33F themselves or us on, Twitter or our actual email. Happy to chat. But yeah, hopefully you all enjoyed it, and feel free to berate the room now, and go nuts on the actual chat, and we'll answer everything while I get a beer.
And here's Andre.
Hello, maybe questions from attendees?
Yeah, I'm just looking at chat now. If anyone has any questions, please feel free.
The first question is, do we get discount?
That is a very focused question.
Yeah, it's probably not one that I'm able to answer.
We will think about it.
For a good point. I think from what I've read, Aaron, that's ruled you straight out. Awesome. Thanks, everyone. I hope you enjoyed. Yeah,
I obviously hope you all enjoyed it. And yeah, by all means, go to X33F website and have a look through the course in detail. We sort of try to label out everything that we're going to be covering. Owen had a pretty hard job of trying to fit that much content into an hour, but I think he did it very well. And like I said, there's plenty more where that came from. We cover a lot in the 3 days, but that factored in with all the courseware that you of course get, and the 21 days access to the lab environment after, as well as the CTF. Hopefully that should give you enough time to consolidate knowledge, go over anything again. You'll get access to our Slack channel if you do attend the training, so we'll be at hand if there are any issues. And hopefully we'll see as many of you as possible there.
See, just to answer your question about blue team techniques, there are some elements to the blue side. So at the end, the course is very offensive. I'm not going to hide that. But at the end of a number of the modules, we will go through various techniques to detect it. Now, there won't be dedicated time to go through each one in regards to looking through Cabana, etc. But that being said, the data should be there for a lot of it, so you can filter through for your own sort of artifacts. And I think that's the say from my point of view, that's the whole reason we put ELK there, so you literally can look for these things as and when you go, and again in the lab time. So there will be a few bits and bobs, but it's definitely a red. The focus is on a lot of the red techniques from the practical side of things. Yes, let me grab that.
Okay, yeah, I was going to say you did see that question. Fantastic. I was just going to say, yeah.
Yeah, I'm just going to. I've got the horrible escape key on a Mac. Where are we? There. I can probably. I'll tell you what. Let me just end this again. Horrible escape key. Let me copy this out. Edit would do, and then we can copy it. Okay, now assuming that's copied. There we go. That's the relevant link. Ah, awesome. You're quicker at typing than I am copying.
So there's a question there about, is this suitable for someone without an offensive background? Absolutely. It is a very technical, hands-on, immersive training course that we're kind of going to be doing here over the 3 days. However, assuming you're sort of comfortable and familiar at a command line in sort of Linux and Windows environments, you don't have to have had years and years of experience doing these types of techniques to benefit from this course, not in the slightest. If you're comfortable, if you've got a working understanding of networks and operating systems, and you are comfortable at a command line, you stand to gain a lot from the course, definitely.
Yeah, definitely echo Will's opinions there. I think the command line, you hit the nail on the head. If you know CLI for it's not necessarily all the commands, but how it works in Linux, Mac, sorry, Linux, Windows, you'll be ready to sort of take on the challenge.
So I think we are 2 minutes over 1 hour, which we planned for this webinar. So I think we can finish right now. If you have any questions, do not hesitate to send to us email or contact us on our website, Twitter or LinkedIn. So I think we can thank you very much for our trainers and invite everybody for our training on November. And please remember about the ZIFCON conference, which is free of charge. So thank you very much. See you soon, and have a good morning, afternoon. I don't know, every day, every hour.
Awesome. Yeah,
So,
thanks everyone.
as far as we're concerned, first of all, thank you, Andre, for obviously hosting us today. Very excited to be training with X33FCon, and thank you all once again for attending. Really hope to see some of you there.
Good morning.
Yeah.
Thank you
Thanks
very
very
much,
much.
guys.
Thanks everyone.
Thank you.
Bye now.
Thank you. Bye.